So here we have a situation with an apple and an orange attached by a rope over a pulley. The apple is on an incline, the orange is on a flat surface, and the two masses are going to move. So we're going to look at the forces involved in actually trying to move this situation. Now the apple is the only one actually trying to move it. If the rope was cut, the orange wouldn't go anywhere and only the apple would actually go down. So really the apple is the only thing actually trying to accelerate the system using its FGX. So if we calculate its FGX using mg sine theta, we can find that the apple is trying to move the system with about 526 newtons. Now, the orange isn't actually pulling. I mean, it's just sitting there if you would cut the rope. So that's my only force trying to accelerate it. Now, both the apple and the orange, of course, have friction, and both the frictions are going to come together to make a total friction to slow down the system. So I'm just going to calculate my forces of friction, and they both have a coefficient of 0.25 to keep things nice and simple. So if I start with my apple on the left-hand side, I'm going to calculate the force of friction, which of course is mu Fn. And when something is on an incline, the Fn is equal to Fgy, and of course to calculate Fgy is mg cos theta. So if I use that, I can calculate that my apple has got a force of friction of about 110 newtons. Now I can do a similar calculation for my orange. Now the orange is easier since it's not an incline. The force of friction for the orange would just be a regular mu Fn, and of course in this case the Fn is just going to be equal to mg. So if I calculate the mg for my orange, mass times gravity times the coefficient of friction, I can see that my orange has about 147 newtons of friction altogether. So now that I got all my basic speeding up and slowing down forces, let's sort of put these things together. In order to actually accelerate the system, there's only one force trying to do it, and that's the 526 for the apple. So I've got about 526 trying to move it. But to slow it down, I've got two frictions. So I actually have to take those two frictions and add them together. I've got 110 from the apple, plus I've got 147 newtons from the orange, and that means my total friction altogether would be about 257 newtons. So let's then put these together, which of course would give me my net force. So my net force would be my total applied force, which is the 526 newtons from the apple, minus all the friction trying to slow it down, which would be 257. So the net force that I'm left with is about 269 newtons, and of course this thing would try and move towards the left. Now that I have my net force, the only thing I really have to do is calculate the acceleration, and of course that's Newton's second law. So for the acceleration, that would be net force divided by mass. And I want to use the total mass. The two masses are tied together, they move together. I want to use the total mass altogether of 130 kilograms. So I've got my net force of 269. I will put these two together to get my total mass, and that will result in an acceleration of about 1.05 meters per second squared. And of course, this system is going to go towards the left.